Good morning, students. Today our topic is pushdown automata in theory of computation. It's nothing but same your finite machine, finite model. So in last videos we know the concept of what is finite automata. So what's the meaning of deterministic finite automata, non-deterministic finite automata? Okay, there is no memory unit in the finite model. There is no memory unit. Both DFA, NFA, it's accept the current input and have the transitions for the current input. There is no previous history because there is no memory unit. If we can't to recall the last input and what's the output. Okay. So to overcome this problem, we go to design the finite model with the memory unit that is known as push-down automata. For the memory concept, we use the stack element for pushing and popping your data. So this is your basic component of pushing finite automata. So here we have three components. The three components are, the first one is stack to perform push and pop operation. The second one is input tape to read your input symbol from left to right. At a time you can read only one input. Okay. And the third one is a finite control. So overall control. It performing some transitions. Some operations performed by the finite control unit. Okay, so the pushdown automata is nothing but finite state machines with memory. Okay, we using the stack concept for memory. Also, the top of the stack. Okay, the top of the stack here. The top of the stack is A, and the input tape symbol A. So both are judged which transaction did perform. Okay, so based on the condition current state P, current state, top of the element in your stack and your current input, the three parameters are very important to performing the transition from one state to another state. So it is totally different from the finite machine. Again one more time I repeat, your current state, starting state Q0 or any Q1, Q2, your input variable, current input variable, and your top of the stack element. These three things are decide which transition to take on next time. Okay. So here I formally define what are the parameters are needed to design the pushdown automata. The first one is set of states, finite set of states, and then input state sigma, then stack symbol. Okay, the stack symbol that will need to push and pop from the stack. The stack symbol and then starting symbol Q0 and then starting symbol of your stack element and your set of final states F and then transition function. These things are needed to develop the PDA. So mostly Q, sigma, and the starting symbol Q0, final state F, then mapping functions are common. Both PDA and finite automata. So here new symbols are your stack symbol and then your stack's starting symbol. That means top of the symbol. These two things are here added. The one more concept that is known as instantaneous description. It shows how the PDA computes an input strings and make a decision. Okay, so the instantaneous description is nothing but shows how your PDA mapping manipulating your input strings and make a decision that strings accepted or rejected. That is described by in the symbol of Q, W, alpha. Q, alpha, W. The three parameters are very important. So based on these three parameters, you can judge the given string is accepted or rejected. Okay, listen. Here Q is nothing but your current state and W is nothing but your input. Starting condition, you have the full length of input. Then after reading the first element, your remaining input still wait to read. In input tape, the remaining input is still wait to read by your finite control. The last one, alpha, is nothing but your stack content, just mean your top of the element. Okay, these three things describes which strings is accepted or rejected, which transition want to make from which state to which state. So everything judged by these three parameters: current state Q and your remaining input, your current input W, and then top of your stack symbol, that is noted by alpha. That is known as instantaneous descriptions ID. And the second parameter is a notation. So notation is marked as reverse of the T. Okay, ma? So it's nothing but you want to move from state Qi to Qj. Listen the diagram on your right side. In pushdown automata, we know that we have input tape and one stack memory unit. Okay. So my current input is A. My top of the stack is X. My top of the stack element is X. Okay. If you want to move from Qi to Qj, mean the two condition must true. Okay. The current input tape is A, top of the stack X, mean you can push the value of Y, push the value of Y before popping the value of X. Now you can understand the notation. Input tape A, when you move from Qi to Qj, your input tape have the value A, the top of the stack X, mean just pop the X value from the stack and push the Y value. That is known as X tends to Y. Okay. So basically, if you want to make a simple transaction, we need 6 elements. You need 6 elements. The first one is your current state and the next state P, U. Okay. This next one is B is your consumed input, your current input, and W is your remaining input, 3 and 4. The fifth element is top of the stack element is denoted as a T, and the remaining your new pushing element is denoted by alpha. So totally we have 6 elements. So this is a working model of the PDA. So my PDA have a 3 parts: the final control and the input tape and the memory unit. Okay. So in my finite automata, I have a 3 unit 1, 2, 3. Okay. I have a 3 status 1, 2 and 3. So in first I read the input value A. So the input tape read the value from left to right. It read the first leftmost element A. Then move to stack element to check the top of the stack is Z. In starting state my stack is empty. So the Z denoted the stack is empty. The Z element denote the stack is empty. So when you read particular input A, just I push the value A in my stack. Okay. Just I push the value in my stack. Okay. So when you read the input B, you can pop the element A or you can push. Both push and pop operation perform based on your application. So PDA is mainly used for check the given string is palindrome or not, or in concept of A power n and B power n, the given string is accepted or not. So everything did by the simple PDA format. For example, here we go to design a PDA for accepting A power n and P power 2n. Okay. By using this PDA, you can designing your PDA for accepting A power n, B power n concept, palindrome, A power n, P power 2n. Okay. It's have a basic solutions. The concept A power n, P power 2n is nothing but when you read a element A, we normally do the push operation. So for push the a in 2 times, because the p power is the 2 power n. In finally both a and b are equal, then these are accepted. So I insert 2 times a in my stack. So the simple logic is, if you read the signal a, then push 2a into your stack. Next parameter, after reading the full length of a, my next input symbol is b. So b power is already 2 power n. So when you read your input symbol b, just pop only one a from your stack. This is the simple logic followed here. Okay. So if the sum is a power n, b power n, when you read the symbol a, just push only one a in your stack. When you read the input symbol b, just pop only one a from your stack. But here the b power is 2, p power is 2 into n, so I insert the a in 2 times. This is the concept. So the instantaneous descriptions here I listed. So first I read the input symbol a. At the starting state, the stack is empty, it's denoted as z. At the starting state, the z, alpha it's a z. So just I push the a in 2 times. So the final value is AAZ. Second time I read the same input symbol a, but here the top of the symbol is a, not z, because I already put 2a in my stack. So the top of the symbol is a. So in this condition again I go to push the double a in my stack. So this is the basics operation. The current state is Q0. We never go to Q1 or Q2. So do the same operation up to read the letter B. After completing A, your next input symbol is B. So you change your state from Q0 to Q1. Your state from Q0 to Q1 and popping your corresponding A. So popping one element from your stack. So there is no parameter to push, just we do only pop operation. So I here put epsilon.